Hi, in this unit we are going to explore valence and core electrons. The electron occupying the orbitals in the outermost shell, highest value n, are called valence electrons. The electron occupying the inner shell orbital are called core electrons. The core electrons represent noble gas electron configurations. Electron configuration can be expressed in an abbreviated format by writing the noble gas that match the core electron configurations, along with the valence electrons. Here is an example. Here, these are the core electrons. These are the valence electrons. In the abbreviation, replace the core electron with the noble gas symbol here, neon, whose configuration match the core electron configuration of the other element. Abbreviated electron configuration. Abbreviated electron configurations emphasize the similarity of the configurations of electrons in the same group. For example, group 1, the first column of periodic table, lithium, sodium, potassium, all these group 1 elements has the S1, okay, S1 configuration. The group 2 has the S2 configuration, similar. This is the periodic table. This version of periodic table shows the outer shell electron configuration for each element. Note that down each group the configurations is often similar, as what we just talked about. The group 1 here is S1, group 2 S2. Here the transition element. Here is the P1, P2, P3, P4, P5, P6. And here is D, and here is F. Okay. In this periodic table, as you can see, here is the atomic number. This is the name of the element. And here is the outer electron configuration, the 1s1 for the hydrogen. Electron configuration begin with the transition element, a scale-densed, atomic number 21 here. Okay, and additional elements are added successively to the 3D subcell. Okay, here is the 3D. Oh, here is the 3D. From here, okay, the 3D here, okay. These subcells are filled to capacity with 10 electrons. For L equal to 2, the d orbitals, they are 2L plus 1 equal to 5 value of ML, magnetic quantum number. So there are 5 different orientations of the d orbital. 5 d orbitals have a combined capacity 10 electrons. For each orbital have 2 electrons. After the 3D subcell is filled, electrons are next added to the 4p subcell. For the 2 periods of inner transition metals, lanthanum, lutetium, and antimonum, lawrencium. As you can see in this periodic table, is from here to here, and from here to here. These are inner transition metals. Electrons are added to an F subcell for the inner transition metal. For L equal to 3, this is a F orbital. They are 2L plus 1 equal to 7 value of magnetic quantum number. This means that 7 different orientation of f orbitals. 7 f orbitals have a combined capacity of 14 electrons. For each orbital can have 2 electrons. There are some exceptions to the order of fitting subcells. For examples, copper and chromium, here and here, these two elements, there is a stability associated with a half field or full field these subcells. Okay. An electron shift from the 4s into the 3d subcell to achieve this stability. Okay, so these are the here, for example, copper here, it is backed. The valence electron is 4s2 3d9. However, actually, the valence electron is 4s1 3d10. There's an electron shift from the 4s into the 3d subcell to achieve this stability. Similarly, chromium expected valence electron is 3d, that's 4s2 3d4, following the oboe principle. Actually, the valence electron is 4s1 3d5. An electron shift from the 4s into 3d subcell to achieve the higher stability. This is some exception, and the two examples here. Electron configuration in the periodic table. Periodic table arranges atoms so that elements with the same chemical and physical property are in the same group. Okay. Elements in the same group have similar valence electrons configurations. The valence electron play the most important role in chemical reactions. This describes why elements in the same group have similar chemical activity. For example, here, the main group element over representative element here. I use the dash square. Highlight these two. These main group elements are those in which the last electron added and enters an s over a p orbital in the outermost shell. This is s here and p here. The valence electrons for main group element are those with the highest n value. N is the principal quantum number. For example, here, galliums. Okay, the valence electrons is like this. The gallium is here in the periodic table. Gallium has 3 valence electrons, 4s to the 4p1. The 3d10 is the completed free 3d orbitals counted as core, not valence electron. Okay. Transition element or transition metal here, okay, are metallic element in which the last electron added to the d orbital here, 3d, 4d, 5d, and 6d here. The valence electron, those added, had the last noble gas configuration in these elements, including NLs and n-d electrons. For example, V, the element here, the valence electrons 4s2 3d3. This element has 5 valence electrons, 4s2 and 3d3. In the transition element here, right here, are metallic element in which the last electron added occupied an f orbital here, 4f and 5f Okay, the valence electron of these atoms have the last noble gas configuration. In these elements, this inner transition element include the ns n-2f, and if present the n-d subcells. Okay. For example, Pn, this element, the valence electron is 4s245f, 4f5. Okay. Pm has 7 valence electrons, 6s2 and 4f5. Electron configuration of ions. Recall, ions are formed when atoms gain or lose electrons, and cation, positively charged ions, formed when one or more electrons are removed from an atom. For main group element, the elements that were added last are the first electron removed. For transition metal or inner transition metals, the highest ns electrons are lost first, and then the n-1d or n-2f electrons are removed. And an ion, negatively charged ion, forms when one or more electrons are added to the parent agent. The electrons are added in the order predicted by the Opal principle. The above content is derived from the book, open textbook written by Flower. Is licensed under the Creative Commons Attribution License version 4. Thanks.